Hello, and welcome to today's workshop. Today we're going to be talking about managing big data for use in a front-end application. And we're going to be doing that by using a Netflix clone as an example. So we'll be developing a Netflix clone using React, the Jamstack, and GraphQL APIs. So let's start with a few housekeeping things. Today's workshop is going to be very much hands-on, and we'll be working out of a GitHub repo. We'll have a link in the description to our GitHub repo, and we'll be working out of that pretty regularly for this workshop. We'll also be using a tool called Gitpod. Now, our goal with these workshops is to make sure that there's nothing to install on your local machine. If you want to work locally, you absolutely can. There are some instructions in the GitHub repo, just some dependencies that our project expects to make sure things are working fluidly. But we'll be using Gitpod, which is a cloud-based IDE that integrates really well with GitHub. You'll be able to launch a cloud-based IDE right out of our GitHub, and it will include a predetermined environment that we know works, that has all the dependencies you need. So it's really easy to get started and really useful. We'll also be using a tool called Netlify. Now, Netlify is a global CDN and a hosting solution for web applications. Primarily what we're going to be using it for today is the Netlify CLI, which is a development tool which allows us to emulate the Netlify environment on our local machine, or in this case in Gitpod. And that allows us to use the serverless function and backend that Netlify provides for us locally, rather than having to deploy it to production to get those functionalities. It makes it very easy to, if you would like to deploy this actually to production, it will provide some tools to be able to do that very fluidly. But we'll be primarily using the CLI tool. And finally, for our database to manage our big data, we're going to be using Astra DB. And Astra DB is a database as a service built on the Apache Cassandra project. It has a lot of really cool features, including a data layer that we call Stargate, that is going to expose our database through various different APIs, including REST, GraphQL, and document APIs. And we'll be using GraphQL today. So today's workshop is definitely geared towards the beginners and intermediate level users. We will walk you through all the things that you need to know to be successful in deploying this app. We are not going to dive too deep into the React side of things as far as UI. We will talk about how to fetch the data from the front end and how to fetch the data from the database using the serverless functions. But everything is pretty easy to understand, and we aim to make it easy to understand. So for today's workshop, you will be able to earn a badge if you would like to. There is some homework that is specified in the GitHub repo. And if you would like to complete that homework and get a badge issued that you can use on social media or LinkedIn or anything like that, you totally can do that. And it's really, really cool. We have several badges, as you can see, for all of our workshops. And we have lots of users taking advantage of that. So we'll have more details at the end. And the homework requirements are specified in the GitHub repo. So check that out. All right, so let's get started with our content for today. We're going to be building a full stack application. Now, what you see on the screen right now is kind of the standard definition of a full stack application, right? We're going to be making a web application. So we have our mobile browsers and our web browsers as kind of the interface to our application. We have our front end, which composes our user interface. And then we have a back end that the front end will talk to, which will then we'll have some functionality in the back end. Usually the back end will talk to the database, and the database is where we're going to store all of our information. This is kind of the standard model. We're going to be doing things a little bit differently today. We're going to be using the Jamstack methodology. And what that means is our application is going to be comprised of the user interface, as well as APIs, which is those serverless functions that Netlify will expose to our front end. Those serverless functions will then talk to the database through an API layer, Stargate, in this case, the GraphQL API, which will expose that data from our database to our serverless functions. So this is what it's going to look like for our application today. We're going to be using React for our user interface, Jamstack serverless functions for our APIs, and those will be hosted in a Node.js environment. And then for our database, we'll be using a Cassandra database through Astra DB, and then GraphQL APIs through Stargate that live on top of it. So let's go ahead and start building this application. We're going to start at the database, and we'll kind of work towards the front end, right? So our database is going to be a Cassandra database through Astra DB. So let's go ahead and start with that. We're going to create an Astra DB. So Astra DB is completely free to get started. All that you need is a GitHub account or a Google account, or you can sign up with a regular email and password. No credit card is needed to sign up at all. It is really quick to get started and completely free. So I'm going to go ahead and sign in with Google because I have a Google account. Feel free to pause the video and sign up. It might ask you like a survey question of why you're using it. Education is, I think, one of the options, and that is a perfectly good answer. So I'm going to go ahead and sign in. Once you sign up, you will be greeted by a dashboard that looks like this. You won't have any databases. I have a couple that are in terminating mode right now. But I'm going to go ahead and create a database. Now you can either use this blue button on the right or the create database up on the left. Then we're going to create a database. Now our database name is going to be workshops, and we recommend following the naming convention that we have here. A lot of the code in the application assumes these names. So easiest path forward is just to use the names that we have here. If you want to use your own, you absolutely can. You just have to make sure you change it everywhere that it's referenced. So our database name will be workshops, and then our key space will be Netflix. And a key space is kind of like a schema or a namespace. It's just a collection of tables. And then for the provider and region, you can select whatever provider you want. You don't need an account with that provider. Astra handles it completely for you. And for the region, you can just select a region that is closest to you. So I'm going to go ahead and choose US Central. And then you can click Create Database. And what this is doing is it's creating a distributed Cassandra cluster of 3 nodes. So there's actually going to be 3 nodes where all of your data is going to be stored in a distributed fashion. So as you can see, my workshops DB is in pending status. It'll just take a couple of minutes to switch to active. And while we're waiting for that, we can get to some other explanation. Okay, so we are using the GraphQL API. Now, Astra DB comes with this Stargate data layer that provides different APIs. Now, we can use any of the APIs that are available to us. We don't have to specifically specify. We have REST, document, and GraphQL APIs. Today, we're going to be using GraphQL. But what is GraphQL? Well, GraphQL was created by Facebook in 2012, but it really gained popularity when GitHub announced their move to GraphQL in 2016. It is an API query language that allows you to specifically request the data that you want rather than just getting all of the data that the endpoint would provide. So typically with a REST endpoint, you would hit that endpoint, give it whatever information it needed, and it would send you back just this huge bulk of data, regardless of whether you need all that data or not. GraphQL lets you specify which data you want, and it just sends that back, which really reduces the bandwidth, and it's really useful for like mobile applications. So GraphQL actually requires a schema to be in place, and you can describe your data by creating types. So for example, we have here a type called project that we're defining as having a name, tagline, and contributors. And the data type for contributors is another defined type called user, and it will have its own subset of data types. And so we can kind of nest these types to have a hierarchy of different of all the data that we have. And you can ask for what you want. So in this query, we're asking specifically for a tagline where the project type has a name GraphQL. And so on the return, under the get predictable results, we see that all we get back is the tagline. We don't get any of the other data. We don't get the name. We don't get the contributors. We just get the tagline. So if we do an analysis on the strengths and weaknesses of GraphQL, we see that declarative data fetching, being able to specify the data that you want, is really powerful. We also have flexible versioning, and it matches the standards using JSON and HTTP. Some of the weaknesses, though, is that it uses a single endpoint, right? We don't have multiple endpoints like we would in REST APIs. We have a single endpoint, and that makes it pretty difficult for security or monitoring. You would have to set up different endpoints if you really wanted to separate that security, which is kind of a downside, a con, if you would. It does have a complex implementation. It is still young and still maturing. But in our case, we're using the Stargate data layer, which simplifies that for us significantly. And caching is pretty hard, but there are solutions for that. Netflix itself uses GraphQL, and it uses Apollo as a good solution for caching. The main target for GraphQL is the backend for front end, as well as mainly mobile bandwidth considerations. All right, so this is kind of our structure that we're using right now. So Astra DB is a Cassandra database. It is hosted on whatever provider you selected, AWS, Azure, and Google Cloud. And then we have that Stargate data layer that exposes these APIs, and we're using, in this case, GraphQL. Now, we have several different tools in Astra to interact with our data through these APIs, and we're going to be using the GraphQL playground to kind of visualize how we're using GraphQL and start inserting some data. If we go back to our Astra dashboard, we see that our database is now active. So what we want to do is first create a security token. So all of our communication to our database needs to be authenticated, and we do that by creating a security token. So on the right in your dashboard, you'll see this ellipses menu for your database. If you drop that down, you can click on the link generate a token. And I'm going to go ahead and select a role, and I'm going to use the database administrator. This is a high-level role, and we're going to be doing things like creating tables, defining the schema, entering data. So we want to, make sure that we have the permissions to do so. So I'm going to use database administrator, and I'm going to generate a token. Now, this token is available only once. If you navigate away from this page, you will not be able to get to this page again. You'll have to generate a new token. So we have a download token details button, which will download a CSV. I'm going to allow. And now I have a CSV downloaded that has all this data, and I can reference that later. I'm going to try and keep this window open just for ease of use. So I'm going to actually open a new tab and go back to my dashboard. All right, so now we have a token, and you don't actually need the client ID or client secret. We just need the token for today. So this token is what we're going to use to authenticate both our GraphQL playground usage and our app. So I'm going to go back to the dashboard. And I'm going to go ahead and click on my database, workshops. And at the top, you see there's several different tabs. I'm going to click on the Connect tab. And on the left side, you have all of our different APIs. I'm going to click on GraphQL API. And there should be a link for the GraphQL playground right here. I'm going to click that, and it opens in a new tab. And now we have the GraphQL playground. Let me make this bigger so it's readable. All right. So the first thing that we want to do, is I'm going to go over the kind of the layout here. GraphQL Playground has two different tabs, as you can see. There's a GraphQL Schema tab and a GraphQL tab. So the GraphQL Schema tab is where we are going to do our DDL commands, or defining our schema. So this is where we're going to create our tables. For the second tab is where we're going to do things like insert data and query data. So we want to make sure that we're doing the correct commands in the correct tab. Otherwise, you'll run into some issues. All right, the first thing that we need to do is authenticate our communication in GraphQL Playground. So if you go down to HTTP headers and click on it, you'll see that there is a space for the Cassandra token. And if we would just replace populate me with our Cassandra token, we can now see that our error is gone and everything is working. All right. So we want to create a table. I'm now in step 3C in our GitHub repo, and I'm just going to copy this mutation out of the GitHub repo and paste it here so we can see it a little bit better. Now, a mutation in GraphQL is how we do edit commands, right? So this is how we would do creating tables or inserting data. Anytime we edit the data or the schema, it's a mutation. So in this case, we are creating a mutation, and we're calling the mutation, we're giving it a name called reference list. And we're running the command create table. We're giving it the key space that we want to create the table in. And we are giving the table a name, and we're naming the table reference list. We have a command here, if not exists equals true. So if there's a table already that exists, it's not going to overwrite it. And then we give it two sections called partition keys and clustering keys. Now, these are the columns that we're defining for the table. And the reason we call them partition keys and clustering keys is because of how Cassandra works. Cassandra is a distributed database. And what that means is the data in each table is going to be distributed around the cluster. And in this case, we have a 3-node cluster, but it needs to know how to distribute that data. And it does that by using a partition key. In this case, we are defining a column called label, and the data type is text. And we're saying that that column, that data in that column, is our partition key. And so that's what Cassandra is going to use to distribute that data around the cluster. And clustering keys is how we define uniqueness. So partition keys plus clustering keys define a unique row. So in this case, we are creating a column called value, and we're defining the type as text, and together the label and the value will be a unique row. Clustering keys also have a unique aspect where you can order the data on disk in a specific order so that when we read it back, it will be in the correct order, the order that we expect, without having to do an order by operation on read, which is pretty expensive. So I'm going to go ahead and click play. And you can see that we are returned the name of our mutation and true. This means GraphQL is successful and it has created the table. All right, so let's go ahead and insert some data into this table. I'm going to go to the next tab, the GraphQL tab. And remember that we have to authenticate again. So the two tabs are pointing at different endpoints. So we need to authenticate this as well. You can open up the HTTP headers, replace populate me with your Astra token. And then there is one other step that we need to do for this. The GraphQL Playground defaults to a endpoint that is not the correct endpoint. So if we go ahead and make this bigger so we can see. All right, there we go. So we have this URL up at the top. This is the endpoint that this tab is pointing to. We have to replace this last part where it's referencing the system, and we need to replace it with our key space, which in this case is Netflix. And once we do that, you can see our error goes away and we are ready to do some data entry. Okay, so I'm going to go ahead and copy the mutation for entering this data or inserting this data right out of the GitHub repo. It's a little bit easier than typing it. I'm in step 4C. I'm going to just go ahead and copy this block and paste it in here so we can take a look at it. So as you can see, we are defining a new mutation. We are calling this mutation insert genres. And this is actually a bundle of multiple mutations, right? And so each of these sections is its own mutation that are going to be executed sequentially. This first one we are naming action. And we are calling a command that's actually dynamically generated by the API, by the GraphQL API. And it is appending the command insert to a name of a table, in this case, reference list. That is the table that we just created. So insert reference list is a dynamically created command to insert data into that table. And you can see that we are defining our values. Label, one of our columns, is genre. And then the other column, value, we're saying is action. And this is going to be the same for all of our other genres. So for example, drama is going to have the label genre and then value as dramas. And then we are also asking for a specific return value. So once it's done executing this insert, it's going to return the value that we inserted. So in this case, it will return action for this one. And for the next one, it will return anime and so on. So I'm going to go ahead and click the big play button, and we can see that we are returned the value for each of these mutations. And this is basically just confirming that each of these genres have been added to the table. So let's go ahead and do a sample query. Let's query the data from this table. So I'm in step 5, and I'm going to just copy this query out of the GitHub repo and paste it in here. So we are defining a query, right? So we're retrieving data. We're not inserting data, so it's not a mutation. We are retrieving data. It is a query. And we're naming this query get all genre. We are querying the reference list table, and we are going to filter by the value where the label column equals genre, right? So we're saying, give me the data from the rows that have the label genre, and then return to me the value. So these are the values that we are asking to be returned, right? And so since we're only retrieving the value, we're not going to be retrieving this label. We already know what the label is anyway. We just want the value. So what this is going to do is just return the name of the genre. So if I go ahead and execute this, you can see that all we get is an array with several objects where value equals action, anime, award-winning, and so on. All right, so let's create another table. We're going to create a movies table. And because we're creating a table, we need to go back to the first tab, the GraphQL schema tab. I'm going to go ahead and clear this mutation out. And I'm in step 6. I'm going to copy this mutation out of the GitHub repo, paste it in here so we can take a look at it. This is going to be very similar to the first create table mutation. We are defining a mutation. We're calling it movies by genre. We're executing the create table command in our Netflix key space, and we're giving the table name movies by genre, making sure if not exists equals true. And then we have to define our columns. And again, partition key, we are defining as genre. Our clustering keys are year and title. So genre, year, and title together will define a unique row. And then we have the rest of our columns, which will just be under values. So we have our synopsis, duration, and thumbnail, and their respective data types. If you would like to learn more about how partition keys and clustering keys work and more about Cassandra in particular, we do have an Introduction to Cassandra workshop as well. Okay, so I'm going to execute this mutation. And as you can see, we have our movies by genre mutation equals true, which means that succeeded. And we now have a movies by genre table. So let's go ahead and insert some data. So I'm going back to the GraphQL tab to insert data. And I'm going to copy the mutation out of step 7 from the GitHub repo into here, and we can take a look at it. All right, so we are creating a mutation, a bulk mutation called insert movies, where we have several mutations. The first one is called inception. We are using that dynamically created command insert movies by genre, because we now have a movies by genre table. And we are providing the values, genre, year, title, synopsis, duration, and thumbnail. And we are requesting back as confirmation the value of title. So what this should do is once it inserts, it should give us back the title for each entry. All right, so let's go ahead and execute this. And as you can see, we have our inception mutation, and we are having returned the inception title, and so on and so forth for all of these entries. All right, so let's do a sample query for these movies. We're going to copy this query out of step 8. And as you can see, we are querying the table movies by genre. We are filtering by the genre sci-fi, making sure that we are selecting just the sci-fi genre. And we are ordering by year descending. Now, this is actually not necessary because we're ordering this data on disk, but this is how you would order by if you were not doing that. And we're requesting the values year, title, duration, synopsis, and thumbnail. So if I go ahead and execute this, you can see that I am retrieving the year, title, duration, synopsis, and thumbnail for each of our movies. So we have Prometheus, Inception, Aliens, and Blade Runner, because we only entered four entries. All right, so this is great. We have inserted data and we are now retrieving the data. But in reality, we're probably going to have more than 4 movies in our database. So what do we do if we have hundreds or thousands of entries and we don't want to retrieve all of that data all at once? Well, we can use paging. So if you move down to step 8b, we'll have an example of how to do paging. So I'm going to copy this out and place it. We're just adding the options field, and we're going to give it the page size of 2. And if I execute this, you'll notice that I'm only getting the first 2 entries. Something else that I'm requesting as a return is the page state. Now the page state is generated by the API, and it is a unique jumble of characters, as you can see right here. And what that does is we can then return this page state back into the request to get the next page of entries. So the way we do that is, I'm going to go ahead and copy this out of step 8c. We're just adding the page state here. So if I replace this page state with the page state that we were returned in our last query, and I execute this, we will get the next page. So right now we have Prometheus and Inception. And if I execute this, we now get Aliens and Blade Runner. So this is how we can kind of iterate through the data rather than getting all of the data at once. We can use this page functionality. So now we have a couple of movies in our database, but we want a huge selection. So if you go to step 9 in the GitHub repo, we have a data set that you can download. And if you download this file, it is a CSV called movies by genre. Just save that to your desktop. And we go back to our Astra dashboard. Let's go into our workshops database again. And at the top, you'll see an option for load data. It's at the top right. If I click on that link, I can then upload a CSV and upload the movies by genre. I'm going to click next. The table name should be movies by genre. This is defined by the file name. If your file saved differently, make sure that this table name is movies by genre with underscores in between the words. That is important. And then if you scroll down, we need to select a partition key. If you remember, we created our movies by genre table with the partition key of genre. And we don't have to do anything else. The clustering columns are predetermined, so we can just click on next. And then for the target database, we are working in the workshops database. And then our target key space should be Netflix. And go ahead and click next. So now that data is being uploaded. You'll probably get an email saying that the upload started, and you'll get another email when it completes. It shouldn't take too long, just a couple of minutes. But what we're doing is we're actually uploading over 6,000 different movie entries. Okay, so while we're waiting for that bulk data to upload, let's talk a little bit about the next steps. We have just created our database and entered in a bunch of data. So our next step is to work on our application. And we're going to be using Gitpod to spin up a predefined environment for our application, which will load up the correct version of Node, the correct version of NPM. If you want to work locally, you absolutely can. The GitHub repo has instructions on which Node version and NPM are known to work. Most of the latest versions should work just fine though. All right, so in our GitHub repo, I am now in part 2, and I'm going to click on this Open in Gitpod button. I'm actually going to open it in a new tab and move this new tab over to my big window. And I'm going to continue with GitHub. All right, so Gitpod is now starting up the environment. It's going to be installing a bunch of different dependencies that are required, and it'll take a little bit of time. While we're waiting for that to complete, let's talk about the serverless functions that we'll be using. Now, all of the code here is already complete, but let's take a look at it. So under the functions directory on the left side, and actually let me make this big so it is easily readable, and I'm going to make the terminal a little smaller. On the left side, you'll see your file structure, and this is based on Visual Studio Code. So if you're used to that environment, this will be very familiar. I'm going to drop down the functions folder, and as you can see, we have two files here, get genres and get movies. These are our serverless functions. So Netlify is actually going to look for files in this directory to dynamically create endpoints based on the file name. So those endpoints will point to these functions that will then get executed when that endpoint gets hit. So we take a look at the function here. This is the standard format for a function. We have an exports.handler equals asynchronous function and is looking for an event. So when this endpoint is hit, it's going to execute this function. Now we are looking for a body, or the event.body. So we're going to be sending information with our request. And the URL is going to be defined by an environment variable called Astra GraphQL endpoint. And that's going to be a unique endpoint to your database, and we'll be entering that data in just a little bit. And then we have our query, and this query should look very familiar because it is a query that we just executed in the playground. We are querying the table reference list, filtering by the label genre, so we want to get the genres. We are defining the page size as something that we define from the front end. So this is going to be sent in with the request, as well as the page state, because we're going to be storing the page state that we get back from each request and then sending that back from the front end to the next request. So that is something that will be bundled with the request as well. And then we are looking for our values. So these values are going to be the names of the genres. And then of course we are requesting our page state so that we can then get the next page. All right, so once that request is hit, it's going to execute this response, this query. So it is a built-in JavaScript fetch method. We are including our application token with our request so that it's authenticated. That is also an environment variable that we'll define later. And then the body is just that query that we just built. And on a success, we get a 200 and we get our response body sent back. And on an error, we get a 500 and an error sent back. The get movies function is very similar. We are hard coding the page size, but we are still looking for that page state from the front end. And we are looking for a genre defined from the front end as well. All right, so let's take a look at how we make these requests from the front end. So these serverless functions are going to be hosted by Netlify in a backend infrastructure that they provide. But how do we call on these serverless functions from the front end? So if I drop down the source directory and I go to app.js, this is our main app file. And you can see that we have a few things here. Here's our React component. We are defining the page size as 4. So this is where we would change the page size if we wanted to load more than 4 genres at a time. We have a few state variables for our requested page, our current page state, the genres that we have existing, and whether we're fetching or not. So this is our fetch method right here. Let's take a look at this in depth. We are checking if we're already fetching, make sure that we're not fetching again at the same time. And then we have our fetch method, right? Our built-in JavaScript fetch method. Now, this is the URL that Netlify dynamically generates for each of our endpoints. It's going to be looking at .netlify/functions/getGenres in this case. And getGenres is the name of our file. So it dynamically creates these endpoints based on the name of the file. And then we are sending in with the body our current page state and our desired page size. And then we're waiting for the response. And in the response, we then need to set our new page state, right? Because we got a page state from the response. And so we are setting our state variable to the new page state. And then we are setting our genres as the existing genres and concatenating the new genres, right? Because we don't want to replace the current genres with the new ones. We want to add to that list and keep it growing because we're going to be doing an infinite scroll type thing. And then we set is fetching as false so that we can make another fetch if we need to. Then if we scroll down, we can see in our return block, this is our UI side of things. We're taking that genre state variable and we're mapping the values to a section component where we are giving it the genre value. Let's take a quick look at the section component. So let's drop down components, go to section.js, and we can see that we have some state variables, movies, our current page state, and then we have our fetch method right here. So just like in app.js, it's very similar. We are now looking at the generated endpoint .netlify/functions/getMovies. And we are sending in the genre that we want, right? Because we're getting movies from a specific genre, and then our current page state as well. And we will be getting movies back from the response. So we set our movies state variable to the values that we get, and our new page state will be set to our page state variable as well. All right, so let's get this app running and see what it looks like. The first thing I need to do is in my terminal, I need to run a command to install the Netlify CLI. So I'm going to go ahead and npm install -g for globally Netlify CLI. CLI. All right, so what this is going to do is install the Netlify CLI, which will allow us to run the app in an environment that emulates Netlify's production environment, right? So we'll be able to have access to serverless functions, as well as the dynamic backend that it generates for us. All right, so now that that is done, we need to enter our environment variables, right? So we're referencing 2 environment variables. We have our GraphQL endpoint and our application token. So to do that, we're going to create a new file. And you can do that one of 2 ways. You can either use the UI here to create a new file, .env is the name of the file, or if you want to use the terminal, you can also run the command touch.env, and that will also create the file. All right, so in here, we need to enter 2 things. And I'm in step 6 of part 2. You can copy this block out of the GitHub and paste it into the .env. But first we need the application token. So in your CSV that you downloaded for your application token, you can just copy that out and paste it in here. If you did not download a CSV, you will probably need to regenerate a token, which is fine. And then for our GraphQL endpoint, we need to get this from our Astra dashboard. So I'm going to go to Astra dashboard. I am in my workshops database. In the Connect tab, I'm going to go to the GraphQL API section. And then I'm going to scroll down and look for the endpoint. It's in number 4 here. And copy this value right here. And this is the endpoint. And this is actually what the GraphQL playground uses as well. So if you still have the playground open, you can copy it out of there as well. I'm going to paste that there. Make sure it ends in Netflix. And that should be everything that we need. So I'm going to go ahead and save this. And now I'm going to just do a quick npm install to make sure all the dependencies are installed for our application. And now that that's done, we will do a netlify dev. And this is going to run the application in that netlify environment. All right, so it should open a simple browser. You can actually click on this button on the top right to pop it out into a separate window. And let's make this big. All right, and as you can see, we have our Netflix clone running. And the genres are being populated here. And you can see all of our movies. And as you can see, only the first 4 genres are being populated until I move my mouse into the next section and it automatically starts loading the next page. And so that's how our genre paging system is working. It actually looks for the mouse enter into that section to load the next view. And for the paging for our movies, you can see if I click on this arrow, it then generates the next page of movies and loads them in. All right, so that is our Netflix clone. Congratulations on getting the Netflix clone up and running. Hopefully you learned a lot about how GraphQL works and how to use that API from the front end to reference big data in your database. So for homework, if you would like to get the Netflix badge for our workshop, you can complete the homework that we showed in the GitHub repo. Basically, it is importing a movie that you like into the DB using GraphQL. You can use the GraphQL playground as shown in step 7, and then get a screenshot of your Netflix clone running in Gitpod, or if you would like to deploy it to Netlify, you can do that as well. And the screenshot should show your custom movie, and you can upload that to the submission form that we have in the GitHub repo as well. And then as an optional homework, there is a video by Anya Kubau, who goes through more of the UI side of things, more of the React UI side of things for this app. And we'll have a link to that video in the description. It is also in the GitHub repo. Thank you for joining today's workshop. We have workshops every single week. We do them live as well. If you go to datastax.com/workshops, you can see the upcoming workshops that you can attend and register for. We also have a Discord of around 18,000 users right now, and this is a growing community of people who want to continue learning and learn from each other. You can ask questions. We're very active in there. We can answer your questions if you have issues with this workshop or any other workshops or any personal projects using Astra DB or Cassandra. We are glad to help. And then please consider subscribing to our YouTube channel. We do workshops every single week. We record them. They are available in our backlog. So if you want to go ahead and subscribe and take a look at those, that would be great. Thank you so much for joining me today. I hope you have a good one and hope you learned a lot. Thanks.